Welcome, students, to our third lecture. I'm going to be talking about a couple different kinds of scale. Remember that scale is one of our vocabulary words in this introductory unit. And there's a couple different ways we can talk about it. One, as a representation of real-world phenomenon at certain levels of reduction, right? A way of reducing real-world phenomenon to a scale that's easier to interact with. What your textbook says a lot is a definition closer to this, right? The relationship between the portion of the Earth being studied and the Earth as a whole. I've got a couple examples of that here. What you see on the right is a to scale model, a 1 to 250 scale representation of ancient Rome. So the idea being that that's 1/250th the size of, actual Roman buildings. Versus a 1 to 1 million scale of a ski resort on the left-hand side there in the mountain range that helps make it up. In this lecture, we're focusing on these two kinds of scale, though. Cartographic scale and analysis scale, or the scale of analysis. Cartographic scale is the scale of a map that you're looking at, right? The relationship of that map to the actual size of the Earth. And we'll talk about a couple different ways that that can be represented. Scale of analysis has to do more with the data that you're showing on a map and the scale that that data is being represented at. And there's all different kinds of levels that analysis can take place, and we'll look at a few of those as well. Starting with cartographic scale, you see the three different kinds of representation that are most common right here, okay? A representative fraction, or sometimes a ratio, or sometimes a fraction, or a ratio fraction scale looks like this. It looks like a fraction or a ratio. This one reads 1 to 62,500, right? Which would be kind of middle of the range sort of map. A graphic scale, which has a sort of, typically a bar with the distances indicated along that line. Sometimes you'll see this called a linear scale or a bar scale. And then you'll see a verbal or written scale where it will state quite simply like that, written out 1 inch equals 1 mile, or whatever the variations might be. Ratio fractions are worth talking about in a little bit more detail here to help clear up any confusion you might have in reading these. Sometimes you will hear maps referred to as small scale or large scale, and you can help determine if that is a small scale representation of the Earth or a larger scale representation of the Earth by the representative fraction that you see. Generally, the bigger the number that's used in that representative fraction, it's going to refer to a much bigger area of the Earth that's being represented. In that case, you would say that the map you're looking at is a small scale representation of the Earth, right? It's going to have a lot less detail, but it's going to show this much bigger area, right? You've reduced a much larger area to this small version of itself on a map. The opposite is true there for larger scale maps, where you're generally going to have a much smaller number as a part of that ratio or representative fraction, right? 1 to 100,000, or even a lot smaller than that, 1 to 25,000 or 24,000. What that means is that smaller number means that a smaller area is being represented on that map, which means that it's a larger scale relative to a global map or something like that. And it's going to have a lot more detail on it. And we'll see some other examples of what I'm talking about here. These are labeled quite clearly, right? The image, the half of this image on the right-hand side shows a small scale map where you see major highways and a collection of towns scattered across this map. Major landmarks, entire mountain ranges are all displayed on a small scale map. On the left-hand side, you see an example of a large-scale map where you are, in a sense, kind of zoomed in this case at a almost neighborhood level, where you see the elevation in the landscape, you can see the names of particular streets and the distances, between those avenues and so on. One way that I like to think about it is that a small scale map is going to have a small amount of detail, right? But show a large area. A large scale map is going to have a large amount of detail, but show a small area. This is San Diego represented at 4 different levels of a representative fraction. From the largest scale representation, which would in this case be which one, if you want to think about it here for a second, probably the 1 to 25,000 here, to the smallest scale, or the 1 to 250,000 scale in the bottom right. You see in the one on the top left, the 1 to 25,000 scale, you can see the individual sort of streets, right, that help make up the neighborhoods at this, particular peninsula sticking out of San Diego. Where on the 1 to 250,000 scale, you're zoomed out and see the entire area of the city, right? Like looking almost at like an entire county here of San Diego, and the various highways and freeways and things that make up San Diego, with the neighborhood level streets becoming reduced greatly in the detail that they're shown. Remember that these are fractions, basically, all right? Or they are fractions. And so you are looking at a representation of the Earth that is that fraction, the size of the actual Earth, right? A large scale map like that 1 to 25,000 map, that is 1/25,000th the size of that neighborhood or that area on the actual surface of the planet, right? If you could make that map 25,000 times larger, it would sort of lay over that entire area precisely, right? And it goes up from there. The map in the bottom right, if you were to make that 250,000 times bigger, then you should be able to lay it over that entire area of San Francisco precisely, right? With all the streets lined up with all the streets on your map and on the actual Earth, if that example makes sense. All right, and that brings us to scales of analysis, which is similar to cartographic scale in that we're looking at different ways of reducing or magnifying something. But in this case, what we're reducing or magnifying is the actual data that's displayed on a map, or messing with the scales at which that data is being represented, instead of the focus of the scale being on the Earth itself. In general, you're going to see terms for scale of analysis, including things like the global scale of analysis, or regional, national, local. But there's a lot of other terms we could use to really zero in on precisely what we're looking at. The value of this is that as you analyze patterns and processes at various scales of analysis, right? As you zoom in from the global to the regional to the national to the local, you can start to see those patterns and processes shift as you analyze something at the neighborhood level versus the country level. You see a lot more precise interpretations of the data emerge when you start to think about it geographically. Okay, so what I've tried to do for you here is get a collection of maps that are all analyzing the distribution of COVID-19 at different scales of analysis. Okay, now a couple notes on this is I'm picking COVID-19 just because it's topical and current, right? And this important thing that we're all paying attention to right now together. It's an example we can all share in. But what's not going to be great about this example is that all these maps are from slightly different time periods, okay? So there's going to be variations that are unintended in the data. I just want to give you some examples of what we're talking about, what you will sort of be seen as something's analyzed at different scales of analysis. A better example would be if I had all of these maps from the same time period, right? Data collected from the same time period. That being said, this is analyzing sort of the global distribution of COVID-19 cases, right? Showing every country, but without any, let's say, granularity of detail within that country, right? All you can see is, how that country is doing overall, right? The amount of cases they have overall. While I'm looking at this one, I want you to think of what map type this is, right? A lot of these maps are going to be of a similar type. What thematic map type would we say that this map is? If you've said choropleth, you are correct. This is zooming into the national level of a scale of analysis, where in this case, we're looking at the United States with each state, in particular, highlighted there. Okay, so you can break it down from the global scale where we could just see the United States as a whole, but no detail as to how those cases were distributed within the United States, to, in this case, this is a good example. This is also from September 4th, like the one from the last slide. You can see finer detail of where those cases are, right? And if you compare the two maps and go back and forth and look at the two images, you can see how analyzing at different scales gives you a clearer sense of how those cases are actually distributed in the United States. This is an even finer level of granularity or detail here, where we've moved into the local level, right? Overall, this map still shows the outline of the United States and its territories, but the data is now being represented at the county level, right? So every county of the United States that has a significant amount of cases is being displayed here. Now, I don't remember exactly when this New York Times image is from, though, so keep that in mind. Also, when we're looking at a choropleth map, something that you would want to pay attention to is how the data is being represented as well. Notice that these cases are in the dozens or so, and this is showing average daily cases per 100,000 people in the past week versus the total cases and stuff that you were seeing in some of the previous maps, all right? Just to be honest about the data that's being shown here. You could zoom in further, okay? Again, this is from April 1st, not September, so the data's different than what we're seeing in these other ones, but this would be at the zip code level, right? Zoomed in so that you can see the separate sort of boroughs or big neighborhoods of Manhattan or New York City, and the actual sort of zip codes, right, at where those cases are distributed. There's a finer level of detail that you can go at least in the United States, where we have these very accurate records at the census tract level. Okay, this shows Washington, D.C., and I've included two different maps here. The one on the left just shows those different neighborhoods, the actual census tracts. These are neighborhoods, groups of a couple thousand people sometimes, that is sort of how they're grouped by the census, right? The areas that the census takers would kind of group these places into, and generally it's even more local than a zip code, all right? And that's one more way of displaying that data. So that has been our lecture on scale, where we looked at several different kinds of cartographic scale, verbal or written scales, ratio or representative fraction scales, and a kind of bar graph or linear scale. And then we also talked about the various scales of analysis, from the global to the national or regional to the local. Thanks a lot, guys, and talk to you again soon.